So the last class we learned about the vapor pressure. So in today's, we are going to cover the hydrostatic. So what is basically hydrostatic? As you can see the name itself, hydro. What is hydro? Hydro is water, right? Static means it is not moving. So the combination of water plus not moving, we call as a hydrostatic. Okay, so hydrostatic condition, if fluid velocity is equal to 0, that means when the fluid is basically at rest, it is 0. There is no motion of fluid, well, either it is liquid or gas. Okay, so in this case, when the velocity is 0, there is no motion at all, no shear stress, only just normal force from the pressure. Okay, so from here, let me draw for you to understand clearly. For example, we have the water in the beaker, in the bottle, for example, and then we have the particle. Okay, this is the water or liquid particle. When there is no motion, okay, there is definitely no shearing stress. This is shearing stress, all right? Remember that we have learned, okay, there is no shearing stress. Okay, this is cancelled. What we have only normal force, which is called the force pressure. Okay, so we have normal, which is must be perpendicular or normal to the fluid particle. How it is normal, you can see here, I try to zoom. Okay, when this is the fluid particle, all right, this is the pressure. Okay, this is force. Should be perpendicular. All right. So this is what it means. Just normal force from pressure. That means the pressure give the force. Okay. So pressure is basically normal force exerted by a fluid per unit area. Okay. I believe all of you know this. The pressure basically force over area. Absolute pressure. So what is absolute pressure? Absolute pressure basically a pressure measured relative to the absolute zero pressure. So, can you guess what's the difference between the absolute and the gauge pressure? Based on the definition here, the gauge pressure basically the pressure measured relative to the atmospheric pressure. So you can see there are lots of relationship, either relate to the atmosphere, either relate to the absolute zero pressure. So what are those? When we look at here, it is better for us to draw, okay, the diagram. Okay, this is for your own understanding. For example, this is the diagram of, okay, the pressure. Okay, this is the y-axis refer to the pressure. Okay, and then the x-axis refer to the absolute zero. That means we start from here 0. We call it as the absolute. Do you still remember what is mean by absolute zero? What do you think of the particle? The molecular. What happened to the molecular when it is absolute zero? Anyone would like to try?
Not moving.
It is not moving, correct. Okay, so that is why we call it as the absolute zero. There is no motion at all for the tiny particles. Okay, we are living in our surrounding now. We are living in the atmosphere, right? Okay, you can see your pressure, but basically our surrounding, okay, full of atmospheric pressure. Okay, so basically our body exerted by the atmospheric pressure from the external surrounding. Okay, so the absolute pressure should be more than absolute zero. Okay, let's say this is our atmospheric pressure. Okay, what the synonyms of uh, atmospheric pressure? Anyone know? Okay, this is we call the synonym we call as a ATM, atmospheric pressure. Anyone knows what's the value of the atmospheric pressure? Do you have any idea what's the value of the atmospheric pressure?
1 ATM.
1 ATM. Okay. The value is 101.325 kilo Pascal. This is a standard value, all right, in terms of standard unit, all right, SI unit. Okay, so 101.325. Absolute zero, that means P equal to 0. Okay, so of course, this is positive more than the absolute zero. So what it means by absolute pressure is a pressure measured relative to the absolute zero. That means the point of reference here is absolute zero. This is the point of reference. Okay, anything refer to this one. This is we call absolute pressure. Because the reference point refer to the absolute zero. Okay. When we look at the gauge pressure, it's basically pressure measured to relative to the atmospheric pressure. So you can see here, now the gauge pressure, the point of reference is atmospheric pressure. Let's say if we have a pressure, all right, let's say we have another pressure. We have this kind of level pressure. Okay, I don't know, this is pressure X. Okay, and then we have this is pressure Y. Okay, let's say this is already, this is pressure A and this is pressure B, for example. So you can see pressure A is more than PATM or atmospheric pressure. So from this reference to the PATM, we call as a P gauge. Okay, this is P gauge. How about PB? This is P gauge of B. Sorry, this is P gauge of A. What do you think of B? Is it the gauge pressure as well when we refer from here to here? Anyone?
Absolute pressure.
Okay, this is, you can see it is value there. The value is, we call as a negative. Negative P gauge. Okay, you can say this one also positive. Positive P gauge. Sometimes we are not calling positive, we just call P gauge. Okay. So you can see PB basically, okay, PB basically is a negative pressure, P gauge. So this is what we call as a vacuum pressure. Okay, do you know what is vacuum now? So when you see the statement vacuum pressure, so automatically you can remember that the vacuum pressure basically the pressure below the PATM. Understand? Okay. So how to get the P? Okay. So what's the relationship in order to get P absolute? Okay. In order to get P absolute of A, for example, okay, P ATM must plus with Okay, you can see P ATM is from here. Remember that absolute is the point of reference is here. Plus with P ATM, you can see P ATM plus with this value. P gauge. So this is what to calculate on the absolute pressure. Okay, so far class, is it clear now? What's the difference between the P ATM
Yes, Doctor.
absolute pressure? Now you understand, yeah? Okay, thank you. So from here, pressure at the point, all right? Remember that I have told you before, this is pressure at the point, right? Pressure at the point has no tangential stress, or we call it as a shearing stress lah. Can exist in the fluid at rest. This is very important. This is particle of fluid. There is no tangential stress like this. No. Okay. Only forces between adjacent surface are pressure force normal to the surface. This is known here. I have told you before. Normal to the face. Okay, this is force due to the pressure. Okay. So pressure at any point in the fluid at rest is the same in every direction. So that means the force here having the same magnitude. For example, this is 10 Newton, this is 10 Newton, 10 Newton, and 10 Newton. Okay. Consider a random wedge shaped element that submerged in the fluid. For example, let me draw for you. Okay. I try to draw nicely. Okay, this is a wedge shape. Yeah. I try to draw a wedge shape. Okay, like this. And then like this. This is the shape of wedge. Yeah. Okay, and then we assign the axis. This is referred to the z-axis. This is referred to the x-axis. Okay. And then into the page, okay. Okay, this is your imaginary. Let me draw the 3D lah. Okay. Okay. Alright. This is let's say this is XY. Okay. So for example, we have a wedge shape element that is submerged into the water, inside the water. So what happened is definitely we have the pressure exert on the surface of the wedge. Okay. Let's say we have the pressure as this one, the green color. We have the pressure normal. Remember the pressure must be normal. Okay, let's say we have the pressure P, which is normal. Okay. All right. Okay. All right, we have the pressure, which is normal pressure to the surface. Let's say we call as a PN, normal. And then we have another pressure which is facing this direction. We call as P. Which direction of P in here? Is it Z or X? Which direction we should refer to?
X.
X, so PX. So this direction should be P Z. Okay. So from here, do we have any other force? Definitely we have the weight from the wedge shape. Okay, let's say this is the weight. Okay, the weight. We call as a W. Alright. So, how to calculate the weight? The formula of weight. Weight equal to mass multiplied with gravity. Okay. So, we know that the mass is what? Is the product of density multiplied with volume multiplied with gravity. So, weight of this element is rho v g. So, in here, what is the volume? How to calculate the volume? The volume of the wedge, which is half multiply with, let's say this is the delta z, the distance from here to here delta z, from here to here delta x, and from here to here is delta y. So, what is the volume? The volume definitely half delta z, delta x, and delta y. Substitute back into the equation, weight equal to density of this element here, not the water, multiply with the volume, which is half delta z, delta x, delta y, multiply with the gravity. So that is the weight of this element. Okay. So from here, after we have know all the forces, okay, let's say this is considered no motion, okay, so static. What is meant by acceleration? Okay, that means the acceleration equal to 0 or the summation of force equal to 0. When we talk about force, definitely we need to deal with vector quantity, which is in the x and y direction. So, from here, let's do this kind of force in x first. Summation of force in x direction equal to 0. Okay, we know that equal to 0. So, what are the forces involved in the x direction? Anyone? Which is px. Okay. Px is a positive direction. We put this way. Okay, to the right is positive. So P, okay, we know that force is equal to, we know that pressure, okay, pressure is equal to force over area. So, in order to get force, definitely pressure must multiply with the area. Okay, so this is the force. The force due to the pressure at x. So pressure at x multiply with the area. What's the area of x? Anyone knows what is the area of px? What's the multiplication? Area of x direction. Area
Delta
this
Y time with
delta.
delta Z.
Yes, perfect. This is the area. You can see here. This is the area. I don't know how to draw. Okay. So definitely the area is delta y multiply with delta z. So from here, the area is delta z multiply with delta y. Okay, this is positive. Another force involved in the x direction, I think there is the force because you can see here we have the slanting here. Pn. Definitely we need to convert into x and y, sorry, x and z direction. So this is Pn. Okay, this is, let's say this is Px and this is Pz. Alright. When we deal with this, we need to use the sine cos formula. Let's say we have the angle. Okay, the angle theta here. So this angle theta will reflect to this theta, the same theta angle. All right. So from here, this px, you can see here, this px is facing to the left. That means it must minus, okay, pn. Okay, is it sine or cos in order to get this theta to the x? Is it sine or cos?
Sine.
Sine, perfect. Sine theta, the area of this face, which is delta y, multiply with delta s. Let's say this is our slanting. Okay, from here to here is delta s. That means the change of slanting. Okay, so delta s multiply with delta y. Okay, next is nothing directly equal to 0. Okay, now we can see that, okay, in order to get delta, okay, in order to get delta z, okay, in order to get delta z, okay, okay, how to get delta z here? Delta z here. Definitely the slanting must sine or cos. Okay, this is conversion. In order to get delta z, the slanting must sine with theta. Okay, clear, yeah? So from here, let's substitute in this formula. You can see we have sine, we have delta s. So here we can replace with delta z. So from here, the replacement become like this. Equal to 0. So what do you think next? Of course, we need to eliminate the same term. Okay. After we have here, we can do the elimination. I believe you already know here. This is basic delta z. Or we can factorize lah. Delta y, delta y. So what do we have now? You can see after we have okay, after we have substitute sine theta delta s with delta z, this is no more already. So we need to delete lah basically. So this is basically delta z, delta, okay, delta y. So we can cancel delta y with delta y. So now our final equation px equal to pn. Okay. So what can you deduce? What can you give reason from this equation? The pressure in x direction is, what do you think? The pressure, that means the pressure in x direction is all the same. Pn, Pn, Pn. There is no difference. Okay. So now let's move on to the force in the, okay, the force in the z direction equal to 0. We try to put this arrow positive to the right, positive to the top. Okay. So what's the force involved? We have P. You can see we have Pz. We have Pz from N as well as we have the weight. So we need to list out the force. Okay, positive first. P Z multiply with the area because this is the force here. What's the area? Delta X multiply with slanting delta. Okay, delta S. And then we have the pressure facing downward. It is negative. Let's say we focus on the Pn. Okay, Pn, it is cos, okay, cos theta. What's the area? Definitely the area is slanting delta S multiplied with delta Y. Okay, and then we have another weak force minus W, which is in this case, W equal to this one. Rho half delta Z delta X delta Y multiplied with G equal to 0. Okay, so from here, we can see that, all right,
I have a question, Doctor.
yes,
Why for PZ the area is X times with S?
this one,
Yes.
let me check, yeah, PZ. Okay, it's not, sorry, delta Y, right? Okay, thank you for notifying me. Okay, now you understand. In order to get the area at the PZ, definitely the slanting here, sorry, the length of X, delta X multiply with the delta Y. Okay, now you can see in order, okay, we do again. In order to get delta X, okay, this one, yeah, in order to get delta X, definitely the slanting one, or we call as the hypotenuse, must cos or sine? Cos, okay, cos theta. So now I would like to replace the slanting delta S cos theta with this one. You can see here. So I want to replace all these with delta X. So now we can use our equation. So P Z delta X delta Y minus Pn delta X delta Y minus rho half delta Z delta X delta Y G equal to 0. And then we can, okay, we can simplify further by cancel out. Alright, let's see, we can cancel out delta X delta Y delta Y delta Y delta Y. And then what do we have? We have Pz minus Pn minus rho, or we call as we put half rho G delta Z equal to 0. Okay, now it is the best if we can make the Pz as a subject. So here Pn positive half rho G delta Z. So that is the equation. Okay, now what can you see? What do you think the pressure in the vertical or Z here? Is there any change when we go into more depth? Is there any change? Different depth will have different pressure or not? Okay, let's say this is the one, yeah? We talk about this one first. Okay, this is Px equal to Pn. Let's say we have the point here. Okay, this is in the X direction. What do you think the pressure here? The pressure at this particle A, B, C, D. What do you think of the pressure? Is it the same or different?
Same.
The same, because this equation prove, right? Any pressure in X direction is equal. This is equal to Pn. This is Pn, 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 the same. How about the pressure in the vertical direction? For example, this is our direction, Z. This pressure, and this pressure. What do you think of this pressure at A? What do you think of this pressure at B? Is it the same or different?
Different. Different.
Pardon? Different. Why different? Prove it. How different? Prove with equation. Remember we have discovered before our equation? What's our equation? The pressure in the Z direction is increasing due to the density of the water. Okay, you can see here, increasing due to the density of water as well as the depth. Okay, delta Z. The more depth, okay, the pressure will increase. Okay, so far you clear about this, everyone? Okay, later on I will share the recording and then this slide, yeah? You will look at and understand. So far clear, yeah? I hope you understand the basic of the static pressure and the variation of pressure at depth. Okay. Okay, please read first and understand. Now we look at the variation of pressure with depth. Remember our last equation, we discovered that the pressure in the Z direction will vary according to the location. So now let's take a deep look into the variation of pressure. So pressure in hydrostatic fluid doesn't change in horizontal direction. This is correct. We have learned. And it will change in the vertical direction, correct? We have proven with the equation. The pressure increase. This is the reason. If you want to know more, why the pressure increase with that? Because of more fluid rests on deeper layer. Okay, for example, this is a beaker. Okay, and then let's say it's difficult for you to imagine. Let's say this is a water. Okay, this is the pool. Okay, and then you swim. For example, you swim. You scuba diving ke whatever. Okay, this is you yourself. Okay, I don't know. Okay, and then you try to fill this pool with water. First layer. Okay, you try to fill this with water. What do you think of the pressure? Is it light pressure or heavy pressure?
Light pressure.
Okay, and then we increase the pressure until this level. Okay, we increase the pressure first. Okay, sorry. First we increase this pressure, and then second pressure. We increase second fluid layer and the final fluid layer. Because of this layer by layer of fluid, it will exert the pressure to the body. Okay. So now you can see, you understand, because of deep layer. Okay. Deeper layer. Effect of extra weight. This is because of extra weight is balanced by increase in pressure. Okay. So from here, let's get the equation of variation of pressure with depth. Okay. Get equation for variation of pressure with depth. That means the pressure relate to the depth. Okay. So let's say we have the element of cube element. Now we are playing with the element of cube. All right. Okay, this cube element. All right. Okay, let's say this is cube element. We have the width submerged into the water. Okay. So this is the axis. Let's say this is Z, this is X, okay, and of course this one, okay, is Y. Okay, what do you think of the pressure? Okay, let's say we have the pressure here. Okay, liquid, the fluid pressure. Okay, we have the pressure. This pressure, sorry, should be. Okay, this pressure still increasing. Yeah, remember our previous equation. The more depth, the pressure will increase. Okay, more pressure. Okay, more pressure. Remember the pressure at the horizontal is the same. Okay, this is the direction of pressure. This is the same, yeah, identical. Okay. Keep increasing the pressure. Okay. So this is the pressure. Just imagine. So from here, we can list the pressure. Okay, this is P1. Okay, P1 pressure. And this is P2. Let's say we put the name lah, P1 and P2. Okay, the change from here to here is delta X. From here to here is delta Z. And we have the weight, okay, which is W. Okay, we have the weight at the center, yeah, centroid. A bit. Okay. So let's say this is from here to here is Z1. From here to here is Z2, reflect to P2. All right. So, all right. After we have drawn here, okay. So what do you think of the force? What do you think the most significant force involved? Is it the force in the X direction or what? Or Z direction? What do you think of the force? Which force is identical? Which direction of force identical?
X.
Okay, identical means the force on the left side is equal to the right side. What do you think of the force? Which direction is identical?
X direction.
X direction. So in this case, just ignore equal direction because it is cancel each other. What do you think is not identical? In Z direction. So let's take a look on the force in the Z direction. So summation of force in the Z direction is equal to 0 definitely. This is static. However, we want to see the correlation of pressure relative to the depth. Alright. So we have the weight. We remember the weight is rho Vg. So the density of the element multiply with the volume. What is the volume? Of course, delta Z, delta X, and delta Y. That means the depth, yeah, delta Y. Multiply with gravity. So from here, what's the force involved? Okay, positive upward. P1, you can see P1 positive minus P2 minus W, which is rho G delta Z delta X delta Y equal to 0. Okay, so from here, okay,
Excuse
we
me, sir.
miss something. We miss something, which is area. Remember?
You missed the half, I guess.
Yes, the area. Yes, perfect. So this is the force. Okay, remember, this is the force, not pressure. Definitely, we must P1. Okay, sorry, yeah. P1 multiply with the area. What's the area? Delta X multiply with delta. Anyone? Delta what? What's the pressure involved?
Y.
Why?
Delta Y. Correct. Minus P2, the same area, right? Delta X, delta Y. Minus with this one. Rho G, delta Z, delta X, delta Y. Equal to 0. Now we can cancel out the same term, delta X, delta X, delta X, delta Y, delta Y, delta Y. So now what we have, Py minus P2 minus rho G delta Z equal to 0. Now, I would like
So what
to...
don't have the half, the rho G half
Okay,
delta Z?
okay, why we don't have the half class?
Cube.
Because the shape of which?
Because the half previously it is the shape of which? You remember? What's the shape of this? This is half, right? Half cube. So it is multiplied with half. You can see. But now it is cubic. So that means it is fully complete. Okay. Is it clear?
Yeah, yes, it's clear. Thanks.
All right. So now I try to rearrange this equation. Okay. I want to rearrange P2 first and then go to P1. Okay. I want to rearrange P2 minus P1 equal to, okay, negative rho G delta Z. Okay, you know that gamma or specific weight is rho multiplied with gravity. So we can also replace negative gamma delta Z. Okay, so this is equation we call as a hydrostatic equation. Okay, so this equation will be used a lot in your next chapter. So if you don't know how to derive, okay, better look at the recording lecture and understand clearly. So what I mean here is, this is pressure. Okay, the pressure involve this is the force involve direction. So now from P2 you can see, from P2 go to P1, this is what it means, yeah. From P2 go to P1, so this is direction. P2 go to P1, the direction here. So it is towards the bottom. So you can see it is negative. Okay, this is important. So from here, we can also write, okay, the change, okay, delta P is equal to also the same with P2 minus P1 is equal to negative integration 1 to rho G delta Z. Okay, this is not really matter lah. The most important thing is this equation. Very important, you need to remember. When we talk about what is hydrostatic pressure, class, it is the change of pressure of P2 minus P1 equal to negative gamma Z. Simple. Or change of pressure equal to negative gamma Z. That's it. Okay, now let's have the quiz time. Okay.
By the way, doctor, I have a question.
Okay, what's your question? What's your
For
name?
Yusuf.
Okay, Yusuf, what's your question?
For the equation gamma equal to rho G,
Okay.
sometimes they use Y, right?
Okay, sometimes they refer to the coordinate. You need to refer to the coordinate. That means this one. If it is 2D, that means X and Y. If it is 3D, that means X, Y, Z. You need to understand the depths. Whatever depths, it is Y or it is Z, whatever. Or it is H, also can be considered. So here, delta Z refer to the depth. Okay. Okay, so
No, I mean the gamma equation.
Okay, the gamma. What do you think gamma?
I think before in previous class we use different symbol.
You use what symbol?
Y. New.
Y?
Something like Y.
New like this.
No. The symbol looks like Y.
Okay, like this. Like this Y. Or like this Y. Which one? A or B?
A.
This one. Is it not the same like this?
Oh, okay.
Okay. Please do not confuse with the symbol, yeah. This symbol here refer to gamma. Okay, gamma, it seems like capital Y, but you should not draw like this lah. You should draw like this. Okay. Okay, let's have a quiz. Okay, I want to see who will be the lucky winner and score the highest mark. Okay, please be ready everyone. We're gonna have the quiz time. I will share you the code. Okay, this is M3. Okay, please go to www.menti.com. Okay, let me share you the screen. Okay, wait ya. Okay, go to www.menti.com. Sorry, this is M2. Okay, wait ya. Let me see the. Okay. Okay, sorry. Go to www.menti.com and use the code 77027781. Okay, please everyone join. I'm gonna record who will be the winner for this.
Look, sorry, I don't know why I cannot join. I don't know why.
Okay, can we start now, yeah? Okay, please answer fast to get more point. Gauge pressure is 3, 2, 1. Time's up. Okay, 7 of you got wrong. Gauge pressure is relative to atmospheric pressure. Okay, remember that. Okay, next, who will be the going to the highest scoreboard? Let's see. Okay, good. We have the faster AY, your nickname. Second, Zarif. Santai. Good. Okay, the last Yi Sheng. Okay, if you got right, you will go to the top 10, yeah? You can see your name here. All right. Let's see who will be the faster and right. Absolute pressure is I'm assuming you already know, but you need to select. Okay, good. Majority of you choose number 1. Absolute pressure is P ATM plus gauge pressure. All right. Who's the first board? Leaderboard. Okay. We have Weng Yu. Okay, good. Weng Yu. Okay, Sal. Sal number 1 ni. Salsabila ni. Okay, and then we have Nuha. Nuha the faster. Okay, it's okay. Salsabila yang lepas. Alright. Question 3. Horizontal pressure is what? I hope all of you got right, yeah? Please got it right. I already explained this one. Remember, the horizontal pressure is the same, okay? Based on our equation, Px equal to Pn. Alright. Okay. Who's the top ranking? Top 10. Okay, Yi Sheng. Okay, the top one. The last TBJ, Daya, Elaine, X-Vance. Okay, Alia. Okay, good. The last part, I think. Okay, second one. The second last. Vertical pressure. This is just to test your knowledge. This is quite tricky. Okay, because why? Because lots of words. Vary in vertical direction only, not only lah. Depend on the density and depth. Okay. Let's see who will be the first. Okay, we have. Okay, Yi Sheng, the fastest one. Good job. We have Ra, Alia, Elaine. Superman hype all day. Okay. Okay, the last that determine the winner. Pressure increase in vertical direction because of what? Okay, finally, who will be the winner? Okay, good. Okay, now I can see majority of you score well. Okay, it is fluid at rest. More fluid rest on the deeper layer, extra weight is better. Okay, finally, who is the winner for this leaderboard? Okay. Okay. Ra, congratulations, Ra. Okay, Ra. Please introduce yourself and explain your strategy. Are you there?
Hello, doctor.
Hi, how are you?
I'm fine. Thank you.
Okay. Introduce yourself and explain the strategy, everyone. Okay, to everyone.
My name is Raffi Akila Hidayat from section 11, doctor.
Okay, section 11. Okay, then.
My strategy is nothing special, doctor.
Okay, what's the nothing special strategy?
I don't know, doctor.
You don't know. Please
Yes.
lah, give advice for us. What's your strategy? At least give one thing. What's your strategy?
Just answer the right question, doctor. Just the right.
Just answer the right one lah. Okay. Any preparation before?
No, doctor.
Okay. Okay. Congratulations, Rak. Okay, what's your name and your metric your name and section, please?
Raffi Akila Hidayat from section 11.
R A
F
F
I
I
Akila Aquila.
Okay, section.
11, doctor.
Okay, congratulations. Okay. Okay, the winners. Okay, good. Okay, I will add a point. Okay, let's take a break 5 minutes before we proceed on the next section. Okay.
Doctor?
Okay, class. Let's proceed on the second lecture. Okay.
Doctor,
Yes.
can we have note for this part of lecture?
Definitely I will share to the
Okay.
e-learning.
Okay, thank you, Doctor.
Okay. By the way, everyone, I would like to test on uh, can this group go to the our WhatsApp group. Okay, I share you the link. Okay, and please join the class group. Okay, please go to your Fleet group. Okay, your WhatsApp group. You can see the link, and then please try to click the link, and then what happened? Anyone? Have you tried to log in? Have you tried to log into the link?
Yes, Doctor.
Okay, what happened? What do you see?
A group.
A group of what?
A chat group. Chat. Like
No. I
Yeah.
mean, you go to your WhatsApp group and then click the link. I just post in the WhatsApp Teams Microsoft the channel.
oh okay.
Basically, my idea is I want to create the channel in the Microsoft team. Okay, every time you want to join the class, just go to the class and just click the button join. Okay, it is not necessary for me to share you the link again and again. Okay, what do you think?
Doctor,
Yes.
may I know the name of the class?
Or you want to search? It is the Fleet One. It is very long lah. Fleet One Fleet One section 11 to 14. Let me share the screen. It is the group. Are you able to?
No, doctor, we cannot get it.
Okay, this. You see?
We cannot get in, doctor. Because
Is it require sign up?
yes. Also, you say that the account needs to be added as an external user in the tenant first. I don't know what does it mean, but yeah, cannot get in.
Okay, after this, can you try to sign up, everyone? And then try to join the class again.
Doctor, I already signed up, but I still cannot find the. You have a code for the class or something like this?
Okay, link. This is basically the link to the channel. Okay, you have signed up, but can you see the button join there?
I have tried to sign up, but it said that sorry, but we are having trouble signing you in. I don't know what the problem.
Oh, okay. It's okay. After this, I will send the invitation email lah. I need to key in one by one your name here. Okay, after this, look at your email and joining the session. Alright, let's proceed on the next lecture, which is the measurement of pressure. Let me share you the screen. Okay. Okay. So, after we have understand on how to calculate the variation of pressure with depth, which is delta H equal to negative gamma G. Okay. So now, in order to, yes.
Have you uploaded this note to e-learning yet?
I see. Let me see. Okay, it is not uploaded yet.
Oh, okay.
Okay, I will share. It's okay. Just focus, and we're gonna have the activity lah. Is it okay?
Okay, doctor. Thank you.
Okay, thank you.
Doktor,
Okay.
sorry for asking.
Yes.
Doktor, yang link doktor baru bagi tu, so guna link tu je lah untuk masuk kelas tu pasal.
Saya plan like this lah. After you have joined the group, every time you have the class, just click the join button there. It is not necessary for me anymore to share the link every time, every class lah. Okay, that is my plan basically. Understand ya?
Boleh
Tapi I will
letak
try
dekat
lah.
description group lah, doktor.
Betul. Okay.
Alright, doktor. Thank you.
Okay. Okay, we learned about the variation. That means certain depth will have certain depth will have different pressure. So how do we measure the pressure? So that means we have the device or equipment to measure the pressure. So how to measure the pressure? We have the barometer. Okay, so you can see barometer. Okay, bar is basically the unit of pressure. We have the bar, we have the Pascal. All right, I think we have bar, we have Pascal, and PSIG. Okay, and then this barometer is basically the device, yeah, measure absolute pressure of the atmosphere. All right, so this device basically function as to measure the absolute pressure of the atmosphere. So how does a mercury barometer works? Okay, that means this barometer contain a fluid which is mercury. So how it works? Okay, let me draw to you. Okay, this is the device. Okay, this is the device. This is a beaker. Okay, and then this is the tube. All right, and inside here we have a mercury. Let's say the mercury color like this. Okay, we have the mercury filled with mercury. And then, so in order to do this, okay, the first step, we have the beaker. Okay, the beaker full of mercury. And then another one, we take the test tube, U-tube here. We take this tube and then we fill up with mercury. And then we try to invert inside the beaker. Okay, and this is what happened when we invert the mercury. Okay, okay, will be filled like this. Okay. Okay. This is mercury. Just imagine lah. This is mercury. So after that, from here, we label here as, okay, we have the pressure. Okay, the surrounding pressure exert the mercury surface. We call as a P2. And inside here, we have the pressure exert the surface as P1. Okay, this is the liquid mercury, Hg. Okay, definitely the surrounding of this exposed to the PATM, atmospheric pressure. And of course, we have the height. Okay, from here to here, which is H. Okay, so based on this one, recap back what we have learned. Okay, hydrostatic pressure is basically P2 minus P1. Okay, P2 minus P1. Sorry, it's a problem. P2 minus P1 equal to negative, or you can say negative gamma delta Z. Okay, so let's say this is P1. Of course, this is 0.1, or we call as a 1. This is 0.1. And this is 2. Of course, this is 0.2. So, from here, we can expand further. P2 minus P1 equal to, okay, equal to negative gamma. Gamma of what? Anyone knows the gamma of what? The gamma of mercury. Okay, so Delta Z refer to here. Delta Z refer to the difference here. So how to get correct? Is it Z1 minus Z2 or Z2 minus Z1? Which one correct? Z1 minus Z2 or Z2 minus Z1? Anyone would like to try? Hakim, Rafi, Akila, Irfan. It is basically refer to this. You can see P2 first. So Z2 minus Z1. This is easy to remember. Okay? So from here, you can see that, okay, let's say this is our reference point, reference line. That means Z2 is equal to, when it is our reference, what do you think of Z2? Is it equal to 0 or have any other value? It is equal to 0. Okay. What do you think of Z1 here? Z1, what is the value of Z1, everyone? Any idea what is Z1?
Yes.
H, perfect. Because Z1 refer to the distance from the reference line. So our reference line is here. Okay, our reference line is here. To the Z1 is H. Alright. So P2, what do you think of P2? Pressure coming from 2. Is it the atmospheric pressure? Yes, P2 here basically refer to PATM. It is a surrounding pressure. So we can replace PATM, P2 with PATM. What do you think of P1? Do you think do we have any pressure at P1 exerted on the liquid mercury?
0.
0.
Small.
A
Almost.
small.
No.
Okay, almost 0. Why 0? Okay.
No particle inside that.
Okay, correct. Okay, let me explain. Why barometer using mercury? Because mercury hardly to evaporate. If we compare with water, other kind of water, when we give the heat, it will evaporate easily. However, for the liquid, due to the bonding strength is very strong, okay, it will not evaporate. So that means there is no particle at all inside here. There is no particle because mercury won't evaporate easily. So there is 0. What do you think? It is vacuum. So when it is vacuum, there is no pressure at all. What do you think? It is equal to 0. Minus 0 equal to negative gamma m. Z2 is equal to 0. You can see minus Z1, which is H. Alright. So from here, PATM equal to negative, cancel positive, gamma MH. So that is what the reason the barometer is used to measure the atmospheric pressure. So do you discover that our PATM it is equal to 101.325 kilopascal? How the scientists get this value? From which device the scientists get this value? Anyone? What do you think? What kind of device the scientists get this value?
Barometer.
Barometer. So the scientists plug in the value of the gamma mercury, the height of the mercury using the experimental method and get this value. Even though the scientist A conduct at Mexico, scientist B conduct at German, the value is the same. Why the same? the atmospheric surrounding us the same, right? We are living in the same Earth. Okay, clear so far? Okay, after you have understand, let's take an example because your course learning outcome for this part is to do the calculation. Okay, you must know how to calculate. So find the atmospheric pressure because as a PATM, when you look at here, just name PATM. If a barometer reading is 740, this is the height. You can see mm. Hg refer to the type of liquid, which is mercury. Gravitational acceleration given, assume temperature mercury to be 10 degrees Celsius. Okay, what do you think of the PATM? Since we derived before, PATM is equal to gamma. Oh, sorry, yeah. Okay, wait, yeah. There is lots of activity. Okay, PATM is equal to gamma of mercury multiplied with the height. It is given here. Height is equal to 740 millimeter mercury. Is this the SI unit? No, it is not SI unit. The SI unit is meter. So 0.74 meter mercury. Okay. Because we need to convert millimeter to meter. We divide with 1000. So density, what is the density? Which is rho of mercury multiplied with gravity multiplied with the height. Just substitute the rho. Rho is given or not? Okay, the rho is not given. Okay, I forgot to put the rho. It is given. Okay, 1350 kilogram per meter cubic. Just substitute the value 13570 multiply with gravity 9.805. Okay, multiply with the height 0.74. Okay, so the final answer will be, okay, what's the final answer? The final answer is 98459.8 Pascal. You can write the best way 9.8.46 kilopascal. Okay, that's it. Okay, you can see why okay, you can see here. Okay, this is the atmospheric pressure. Why there is the difference between our standard? Because you can see it is at 0. It is at mercury 10 degrees Celsius. Different temperature will give different, okay, different density property, yeah. Okay, so sea level atmospheric pressure value. Okay, when we are surrounding by atmospheric pressure, how do we determine our reference point? Anyone? How do we know our reference point? Which point our reference as the height? For example, previously we do this one. We consider our reference point at here. What do you think at Earth? Our Earth.
The sea level.
Yes,
Sea level.
definitely. The sea level is our reference point. Okay, so that means the sea level we consider as 0, 0. Okay, why not consider as the any kind of mountain as the reference? Because we have so many mountains. Maybe mountain A different point, different height. Mountain B different another height. How about the sea? Do you think the sea will be the same surface? It is the same, right? So that is why we consider sea level as our reference line. So based on our reference line, it is measured that the pressure, atmospheric pressure, based on the atmospheric sea level, 14.7 psia, pound per square inch absolute. You can see A refer to absolute. Sometimes they put it PSIG. It is gauge, pound per square inch gauge, pound per square inch absolute. Right. We have the, you can see we have the, this is the imperial unit. And this is the SI unit, 101.325 kilopascal. This is in terms of inch mercury, and this is in terms of millimeter mercury. Okay, the next part is manometer. Basically, the manometer is the most important part throughout your course. Okay, why the manometer is very important? Because you're gonna have lots of example using the manometer. Okay, what is manometer? Okay, manometer use the hydrostatic equation. Remember our hydrostatic equation? P2 minus P1, okay, equal to negative gamma, okay, Z2 minus Z1. Right, this is our hydrostatic equation. Alright, so manometer consists of U-tube shape. Okay, it is made of glass or plastic. Any kind of fluid like water, mercury, alcohol, oil can be put inside the U-tube manometer. Okay, so what it looks like? It looks like this. We have the U-tube. Just draw U. Okay, and then this is tube. This is the manometer device, yeah. Okay, and then we have the pressure. Let's say this is pressure at point X. Okay, and then this is like this. And then we fill up with mercury. Okay, we fill up with mercury. Let's say this is what. We fill up with mercury. Okay, let's say this is already have pressure. So we fill up with mercury. Let's say this is our mercury. Okay, you can put any other of fluid like oil, alcohol, water, whatsoever, or you can put any other of liquid lah. For example, you put another one like this. This is maybe oil. Or you can have so many of the fluid lah, basically. Okay, so this is like oil. This is mercury. And on top of this, we have PATM. Okay, atmospheric pressure. PATM. The PATM will exert the pressure here. Remember, our surrounding, we call as atmospheric pressure, exert on top of the surface. The whole device, you can see, is what we call as a manometer. Okay, it is a U-tube shape. So now consider the following column of fluid. Okay, now we focus on this part. We try to focus on detail. Let's say we consider this one in detail. Yeah, we take a look in detail. Consider following columns. Okay, we have few columns here. For example, like this. Inside the column, okay, we have inside the column we have, okay, this is our base lah, reference. Okay, this is, okay, first we pour liquid. Okay, let's say this is liquid. Okay, this is liquid density D. Okay, and then we pour another liquid. This is liquid. Okay, liquid C. And then we pour another liquid. This is liquid, let's say liquid B, and finally liquid A. Alright, so from here we need to name our level. This is Let's say this is P1. Of course, this is Z1. This is P2, Z2, and so on. Alright. Z5, Z4, Z3. So, how to get the equation? Okay, this is very important. Since we have 4 types of liquid, that means every liquid will have different pressure, right? Because pressure relates to the density. Different density will give different pressure. You cannot sum up all. You have to sum one by one. Okay, so let's start like this. Okay, this is very important. From the top to the bottom calculation. Remember this. Okay, and then have the reference point. This is our reference line. Okay, after that, equation of hydrostatic equation. Okay, we start with P1 go to P2. So our hydrostatic said P2 minus P1. So from here, okay, sorry, P2 minus P1. Okay, I want to go from here. P1 go to P2, that means P2 minus P1. Alright, equal to negative of what? Rho of A. Gravity, which is Z, Z2 minus Z1. Okay, plus with P2 go to P3. So definitely P3. Oh, sorry. Definitely P3 minus P2. Alright, equal to negative rho of B. G Z3 minus Z2 plus P3 go to P4. So P4 minus P3 equal to negative rho C Z4 minus Z3. Make sure it is the same, yeah? 4, 4, 3, 3, and 2, 2. Alright. So after that, P4 go to P5 plus P5 minus P4 equal to negative rho D G Z5 minus Z4. Alright, and then make this equation. So you can see P2 we can cancel with P2. P3 we can cancel with P3. You can see P2 minus P2, P3 minus P3, and P4 minus P4. So finally, what do we have? We have P5 minus P2 or P2 minus, P1 minus P5 or P5 minus P1?
5 minus 1.
Yes, P5 minus P1 because this is plus. So all the equation here, you factorize G outside, bracket rho A, Z2 minus Z1, unit 2, okay. This is factorized negative here, and then you need to plus all. You need to plus this, okay. Rho, what we call it? Rho B, Z3 minus Z2, okay, plus rho C, Z4 minus Z3, plus finally rho D, Z5 minus Z4. Okay. That is actually how you calculate the pressure difference between P5 minus P2. Okay, so far any question, class?
No, doctor.
No, doctor.
Okay, we try one example after because this is very important. You learn about this. Okay, I want to give you one example. Okay. So for example, this is our manometer. We draw the manometer. And you can be like you, okay. Okay, nice. All right. And then you have the pressure right here. I don't know lah, maybe this is point A. Okay. And then you pour a liquid. Okay, you pour a liquid. Okay, until this section. Okay. Because this is having the height because of the pressure difference at A. So this is PATM, atmospheric pressure. So from here, you need the first step in order to calculate the manometer device. You need to start with the reference line. You need to start with reference line. Let's say this is our reference line, reference line RL. Okay, and then you need to have the direction of your measurement. Remember this one, you can see from top to bottom. So from here, definitely you can start from here, the direction. Okay, this is the direction. After you set the direction, you set the point. Okay, this is, let's say this is Z1. Okay, and then the neighbor here, the same distance, the same height. Let's say this is Z2, and this is of course Z3. Okay, and then we have the density A because of the liquid A, I don't know the gas A, and then we have the density B. Okay, so how to calculate? Very simple. The first step is like this. Remember our hydrostatic equation? P2 minus P1 equal to negative rho, okay, G Z2 minus Z1. So we start with P from here. A go to Z1. We start from here. So what's our equation? So P1 minus, anyone? P1 minus what? PA equal to negative rho of A G Z1 minus ZA. Very simple. Plus, okay, you can see Z1. Okay, this is your drawing from here. Okay, you can see Z1 go to Z2. Do you think the pressure is the same? Z1 equal to Z2 or different? Remember our pressure in the horizontal, is it the same or vary? Same. So we can skip, we can jump from Z2, we jump to from Z1, we jump to Z2. So Z2 go to Z3. So our equation Z3, sorry, not Z, P, okay, P3 minus P2 equal to negative rho of B, because we are dealing with the liquid B here, G Z3 minus Z2. So equal to, you need to cancel. Okay, P1 and P2, is it the same? P1 equal to P2? Pressure? Yes, the same, right? So we can cancel P1 minus P2 because it is the same. So what do we have now? P3 minus PA equal to, you can put this way lah, negative G bracket rho A Z1 minus ZA plus rho B Z3 minus Z2. Okay, that's it. That is the equation of hydrostatic that you use to calculate the pressure in the manometer. Okay, the pressure difference between pressure at 1, pressure at 3. Okay.
Doktor,
So what do you
P3 tu
think?
PATM
Baru nak cakap. Okay. What is a P3?
PATM.
PATM. So you can replace basically PATM minus PA equal to the same thing. Sama lah Can bawah. Okay, clear so far? Alright, I think okay. For this part, I want you to focus because this is involved of the parameter. I want you to look at how to get involved in the calculation. Okay, focus clearly, yeah. Okay, closed tank contain air and oil. Given the specific gravity here, okay, 0.9 as shown. Okay, I will draw later on. A U-tube manometer containing mercury is connected to the tank as shown here. Okay, I will show lah later on. Column height are H1 36, H2 6 and H3 9 inch. Okay, now we are dealing with the imperial unit. Find the pressure reading in the gauge in PSI. Okay, so this is PSIG, pound per square inch gauge. Alright, so let's draw. I draw nicely. Okay, try. This is the tank. Okay, this is the tank. Let's say this is the tank. Okay, the tank connected to the U-tube, remember? Okay, try to draw. Alright. Okay. This one open to the air. So that means atmospheric pressure lah. And then fill with the okay. The closed tank, this is the closed tank. Contain air and oil. Definitely fill with oil. Okay, let's say we have oil here. Okay, definitely fill with oil, and then the manometer containing mercury. So let's say this is the mercury. Okay, from here to here we have a mercury. Okay, this is oil lah. This is oil. Okay. This is oil and this is mercury. Okay, let's say this is mercury. Hg. So this is air. Okay. Air. This is PATM when this is exposed to the air. So how to do this? Okay, this is oil. Right, and it is given that H, okay, from here to here. Alright, so yeah, 36 H1 here, H2 here. Okay, this is H1 and this is H2. Okay, this is inch. Alright, and then from here H3 is from here to here. Okay, 9. So this is H3. Okay. This is mercury, Hg. Okay, the first step, what we need to do, we need to set our reference line. Okay, the reference line you set, you must follow that. That means this is optional. You can have many reference. You can have any point. For my case, I want to set this as our reference line. So that means any measurement must refer to reference line. Okay, because why? Because you can see H3 relate to RL. You can see H1 and H2 relate to RL. So it is better I put reference line in here. So and then have the direction. I want the position. I want the calculation start from here and finish here. Okay. So what to do? Our equation of hydrostatic. Hydrostatic equation is okay. P2 minus P1 equal to negative gamma or rho G. You can put rho G lah ya. Rho G Z2 minus Z1. Alright. So we start with P2 minus P1. So from here. Okay. So from here. This is P of F. Okay. And then we have P1. Okay. So from here. We start from here. Go to here. Right. Okay, this is, let's say this is 0.1, reference line is 0.2, and this one is 0.3. All right, so from air go to 0.1. So what do you need to do? P1 minus P of air equal to negative rho of oil, okay, gravity multiply with, okay, what is the value of a Z1? Anyone know? Okay, anyone knows what is the value of Z1? Are you there?
H3.
Okay, this one, this value, refer to this point. What's the value of Z1? Is it the same level as reference line? Anyone? When it is the same level, what do you think reference line? Is it the Z1? Z1 equal to 0. Okay. So 0 minus P of air. What's the value of P of air? What's the value? H1 plus H2. What's the value of H1 plus H2? 36 plus 6, right? You can see here. This is in the unit of inch. Do you think the standard imperial unit is inch or foot? You still remember inch or foot? Foot. So we need to convert into foot. Divide with 12 inch. 1 foot is 12 inch. Alright.
Doktor.
Yes.
Dalam exam guna inch foot ke just metric?
Depends. Sebab depends because we need to master you to both unit. Either imperial or SI. So you must know lah. Okay tak?
Okay, doktor.
Okay. So after from point A to 1, so 1 go to, okay, you can see 1 and 2 is the same. So we jump from 1 going to jump point 2. Okay, because 1 and 2 is the same. Pressure at 1, the same is 2. We can jump. So from 2 go to 3. So P3 minus P2 equal to negative rho. What do you think of rho? Rho of Mercury. So what is the Z3? What is the value of Z3? It is based on our reference line. What is the value of Z3?
H3.
Which H3? What's the H3?
9.
9. Divide with 12 inch, because we need to make sure our calculation is standard imperial. -0. Okay, why 0? Because Z2 is our reference line. Okay, no more, nothing. Alright, so P1 we can cancel with P2 because P1 is the same with P2. So what do we have? P3 minus P of L. Okay, and then the rho. How to get the rho? The rho of oil. How to get the rho of oil? Anyone? Remember specific gravity? What's the formula of specific gravity? Which is rho of oil divided with rho of
Water.
water. Alright. So density of oil basically is equal to specific gravity of oil multiplied with rho of water, which is, what is the rho of water? What's the rho of water?
1000.
It is 1000 is the SI unit, the imperial. The rho of water is 62.4 pound per feet cubic. Okay, remember that. So the density of oil is negative. Specific gravity of oil, which is 0.9 multiplied with 62.4 multiply with this number. Okay, negative 3.5. All right, and then minus with this one here, rho of oil, which is okay, rho of mercury, which is specific gravity of mercury multiplied with density of water. So density of mercury is given already, specific gravity 13.6 multiplied with 62.4, density of water. Okay, and then I multiply with the, what we call it here, the value here, 9 divided with 12, it is 0.75. Okay, so the final answer is, okay, 3.055 LB. Okay, LB. Sorry. The final answer is 3.0. The final answer is 439.92 LB per F square. Okay, remember that the unit is pound per square inch. So we need to convert into inch. So how to convert? You can do the conversion. Okay, feet square into inch square. Okay, one foot equal to 12 inch. So you can do the conversion. You know that P. Okay, this is PL. P3 refer to atmospheric pressure. When this is considered as the gauge pressure, that means our relative pressure refer to the atmospheric pressure. So this is equal to 0 when it is the gauge. So we have negative P of air. You do the conversion, you will get the answer is negative 439.92 LB per feet squared. You can do the conversion lah. Okay, 1 foot, okay, square equal to 12 inch square. Okay, after the conversion, you will find the answer is 3.055 pound per inch square. Okay, So this is actually referred to 3.055 PSIG. That is the final answer. Okay. I think that's all for today class. Okay. I hope that you learn. The next class we're gonna have the breakout session. Please study the lecture note and we're gonna have the session. Okay. Anyone haven't scanned the attendance?
Doctor.
Yes. Okay. Yes. Yeah. Please proceed.
Doctor, this note will be on e-learning.
Will be on the e-learning after this.
Doctor,
Okay. Yes.
the G for the 0.9 times 62.4 times negative 3.5.
Okay. Which one? Yeah.
For the P3 minus PA equals to negative 0.9 times 62.4.
Yes. This one. Okay. What's
For
your
that one,
question?
need to times G or not? G?
Which one? Okay. Yes. Correct. I forgot to multiply with G. Okay. Correct. We can make like this lah. Okay tak? Okay. Okay. Is it clear? Multiply with G all. Because we have compact equation, right? We have rho G. You have multiply lah with G. G is the same, yeah. Okay, thank you for notify me time BG. Okay, I think that's all. I hope that after this, please revise and we're gonna have the activity for the next class. You can see breakout room. All right.
Doctor.
Yes.
Can I ask why is P3 0 again?
Okay, P3. You can see P3 is referred to atmospheric pressure. All right. Remember, okay, do you know that P3 is equal to PATM? Is it clear? Or you haven't know this?
Yes, I know.
Okay, so why it is equal to 0, you mean?
Yes.
Okay, you see the question, find the pressure reading in gauge. So remember what is gauge? It is the pressure relative to what?
Atmospheric pressure.
Atmospheric pressure, so that means atmospheric pressure equal to? When it is our reference, PATM, equal to 0. Clear?
Clear.
So that means it is 0. Clear, yeah?
Clear.
Okay. I think that's all. Any question? Okay, I assume no, yeah? Alright, I think that's all. If you haven't scanned the attendance, please do so. I end my session with Assalamualaikum warahmatullahi wabarakatuh and all the best.
Thank you, Doctor. Thank you.
You're welcome.
Thank you, Doctor.
Thank you, Doctor. Thank you, Doctor.
Okay, welcome. Okay, thank you.
Doctor,
Yes.
I have problem scanning the code.
Okay, what's your section?
Section 14.
Okay, let me share you the real codes. Section 14. Oh, okay. Wait, yeah, I think there is a server juga lah. Wait, yeah. Let me open back. Restart again. Let's see what happened. Okay. Okay, can you try again? I have opened the section 14. Can you try? The total class is 8, but I noticed that someone extra scan. It is 9 over 8. Okay, are you able to scan section 14? Okay, I assume all of you have scanned. Okay, I close the session here. Alright. Okay, bye everyone.
Thank you, Doctor.
Okay.